Okay, so last lesson we learned about the sulfate ion and the resonance that exists within the ion, but what we need to be able to do now is try to figure out which one of these structures is correct and how do we make that structure. And the way we do that is by using something called formal charge. So the way formal charge works is it assigns this particular charge to every atom that's involved in a molecule or an ion. And we determine that by taking the number of valence electrons that are in the molecule or the ion, and we subtract from that the assigned electrons. Well, what's an assigned electron? Assigned electron is anything that's a lone pair of electrons. Those electrons are assigned to that atom. So here's a lone pair of electrons. They're specifically assigned to that atom. Here we have a bonded pair of electrons. That bonded pair is cut in half. One of the electrons is assigned to one atom. The other electron is assigned to the other atom. So let's take a look at, for example, this molecule right here. I'm going to find the formal charge on this oxygen. So if I look at the number of valence electrons oxygen has 6 valence electrons. Now how many assigned electrons does it have? Well, 1, 2, 3, 4, 5, 6, and here's a bond, so one of those electrons. So 6 valence electrons minus 7 assigned electrons, that gives us a -1 formal charge on that oxygen. To show that, we're just going to draw a negative sign and do that. If I do it here, it's exactly the same scenario, exactly the same scenario again, and exactly the same scenario again. Let's look at the middle sulfur here. The middle sulfur, again, has 6 valence electrons. How many assigned electrons are there? Well, we have 4 bonds, and 1/2 of the 4 bonds goes to that sulfur, so 6 minus 4 gives us 2. So on the central sulfur, we have a +2 formal charge. Now looking at this, we want to reduce formal charges. The best Lewis structure is the structure that has the smallest amount of formal charges, and formal charges are distributed as far away from each other as they possibly can be. We don't want to have a bunch of concentrated charge anywhere. You don't have a lot of positive charge. Those positive charges would be repelling one another. So we have everything here as a formal charge. That's not a very desirable situation. Let's look at this one by comparison. Here, this oxygen is very similar to this oxygen, so I'm just going to automatically put a -1 formal charge here and a -1 formal charge here. Let's look at this oxygen now. This oxygen is different. It has a double bond. How many electrons are assigned to it? 1, 2, 3, 4, 5, 6, half of each bond. So 6 valence electrons minus 6 assigned electrons. There's no formal charge on this oxygen, and for the same reason, there's no formal charge on that oxygen. How about the central sulfur? The central sulfur, 6 valence electrons. It has 6 bonds, 1, 2, 3, 4, 5, 6. Half of every electron in that bond, 6 minus 6, no formal charge there. So in fact, this one only has 2 formal charges. That one has formal charges all over the place. That is not a desirable situation. That indicates to us that this is a better Lewis structure than this. If I take a look at the central sulfur on this one, and this molecule here, or this ion here of sulfate, here I have no formal charge for the same reason I have no formal charge here. So no formal charge, no formal charge, no formal charge, no formal charge. But now the central sulfur has 6 valence electrons, but 8 assigned electrons. 1, 2, 3, 4, 5, 6, 7, 8 bonds. So it would give me a -2 formal charge. Again, I don't want to concentrate my charge. Charge does not like to be concentrated. Charge likes to be distributed. So of these options, 1, 2, 3, the second one is the one that we would go for. So in formal charge, you're always looking to reduce formal charge and distribute your formal charge. So now you're going to do some practice where you draw some Lewis structures, analyze them to see if they're the best one, and assign their formal charges.